when I was trying to get some statistics, I found a magical number that maybe about 20 to 30% of the research data sets are fair. Maybe this is optimistic, but we will hear more about this later. So before we go deeper into the topic of data, I wanted to start with what open and responsible research and innovation is, and what open science is, because it seems that we discuss a lot these concepts, but we heard about the terminology and that sometimes it's not really clear, there are overlaps, there are confusions. So when we are using this abbreviation ORI, or we speak about open responsible research and innovation, we have in mind research, development or innovation processes which consider the potential impacts of technologies on the environment and society. If I ask you to give examples, probably everyone would think about the development of the nuclear bomb as a technology, so we can discuss how responsible this was from the perspective of time. And the trick here is that when we do our research today, maybe it's a bit difficult to imagine all the consequences of this research, but we try to do so. Within the open and responsible research and innovation, there are 6 pillars. So they're in the center, and we have open access, something which appears also under the open science umbrella. We have governance. The idea is, I already mentioned earlier, that different types of stakeholders are involved in the processes of planning and delivering research. We have the gender equality, we have ethics, we have science education, and we have public engagement. So I used some of these when we were trying to rank what's important, or where the Bulgarian researchers think that they have most experience. So the 6 pillars are sort of floating within the various stakeholders, which include the research community, but also the policymakers, the education community, the business and industry, and the civil society organizations. And all these are sort of also taken from the point of view of some major principles, which are to have more diversity, more inclusiveness, more openness, more transparency, more reflection and anticipation of the potential impacts of our research, and also responsiveness and adaptiveness. Now I jump to another diagram, which I'm sure many of you are familiar with. This is the UNESCO diagram on the pillars of open science. So from 6 components we jump to 14, but this doesn't mean that they're again nested into each other. There are some overlaps, and this creates sometimes confusion. So when we speak about open science, we have 4 areas. One is the open scientific knowledge, which includes the publications, the research data, the educational resources, the open software, and basically this is what we produce and we deposit somewhere so that various other people could get access to it very easily. Then to do this we need infrastructures. This is why I think UNESCO chose the puzzle shapes. Without the infrastructures where we deposit all this, we can't really share it very easily. And here we have virtual infrastructures and physical infrastructures. So EOSC in a way is a virtual infrastructure, but to be there it needs physical equipment, servers and everything behind, the cloud and so on. Then we have the engagement with different societal actors. And here we have the crowdsourcing, the crowdfunding, the engagement of citizens in citizen science projects, and the communication of science. The last bit, the blue one, is the one which probably is most difficult to sort of integrate into our Bulgarian understanding of communities. This is the open dialogue with other knowledge systems. This came from environments where there is a big interest now to capture the indigenous knowledge, the knowledge of different nations and tribes, which is different from the mainstream knowledge, and to look into different knowledge systems. We can't relate entirely to this, but there are also two other circles, the marginalized researchers and also the local communities, communities which have specific relationship with research or have no relationship with research at all. So what is the difference between these two coexisting paradigms? This one is very practical. It gives you the tools which you can use to share, to also speaking about the infrastructural aspects, how we can engage citizens and what we try to integrate into our research. Here it's more about the principles, and we see that open access is part of the picture, but there are also some forms of engagement, like the public engagement and the science education, and some underlying ethical and gender equality principles. What is really very important here, which doesn't come through the UNESCO diagram, is the governance aspect, where we try to put all stakeholders to work together. So in a way, both views are very important, but they work on different levels. And you will say, okay, we look at open data, and here this is only one circle from 14 different circles. In reality, these circles also have their inner connections. So all we know that now with publications you can deposit data sets. So the other circle of publications is related to the open data. If we develop software in open source, it's also linked, it was probably tested on some data sets, you can create this connection. If we speak about open educational resources, again, for some educational resources, you probably would be using data sets. So in a way, these circles are not existing as bubbles which are not related. These are not silos. This is a system where everything is communicating to each other. If you look at the other end of the diagram, we have the engagement with different actors. So if we organize a citizen science project where citizens contribute to a data set, here we have a process which can generate something which comes on the opposite side of the diagram as a data set. Obviously, data sets reside somewhere in virtual and physical infrastructure. So we say data, but it's actually, if we start analyzing what is it, it's underpinning and connected to everything else in the diagram. But what is research data? Everyone could give different definitions. I use here one very popular definition from OECD, which says that these are factual records, which could be very different: numerical scores, textual records, images, sounds, which are used as primary sources for scientific research. And what is very important, they are commonly accepted in the scientific community. So the community role here is quite important. Also, research data sets constitute a systematic but partial representation of the subject being investigated. I think this is quite important. So we have something which is presented in a data set form. We can now say that besides the numerical scores, texts, images and sounds, we can use videos as data. Technology is constantly developing, but they don't exist just for the sake of creating a data set. They give us some representation of a subject. It gets even more interesting. So here we have plenty of people from the humanities, and now if we look at what is happening with the large digitization efforts of libraries, archives, museums, galleries, we have this concept, very popular in the last decade, of collections as data. When we have digital collections, we have digital objects and they can be treated as data. It's a difficult transition in the thinking, but I took here an example from the British Library. So the British Library has a repository of data sets which are based on their digital collections. Everyone can go and explore what they have, which could be from post stamps to Hebrew texts, maybe some Chinese, I haven't checked about this, maps and so on, sound collections, lots of different types of digital collections. What is interesting is that you have over 700 digitization projects which produced various data sets. That's one library, obviously a very big one, but just to illustrate the complexity and how much data we actually can handle potentially. What is also interesting is that 1/5 of those data sets are openly licensed, and still to use 80% of the remaining data sets you have to go on site. So a nice trip to London to use some digital resources. So very quickly, if you look at the data, they're part of life cycles, and we can look and zoom into two life cycles. The life cycle which represents the data life, and Sarah touched on some aspects of this. For each of these stages you need different skills to be able to handle data. The other life cycle is the life cycle of research. So if we speak about data, we create data, process, analyze, store, share and reuse. A little bit more explanation, we can create them in multiple different ways. We can get data from Internet of Things devices or from other devices. We can extract them, or we can ask people on the street a question and record this answer. So depending on the different research domains, we have numerous different processes. Then we probably will need to clean, to create samples, to anonymize in some cases, to convert, enrich, to tag, and this is all under processing of data. We can then analyze the data using different other methods. Every step here requires different skills. The skills to capture data, to process them, to analyze them. And then we would store the data for long-term preservation. But which version are we going to store? Are we going to store the raw data we collected at the creation stage? Are we going to store the cleaned data? Are we going to explain what we did, what we collected, and then how we cleaned it and why we did so? Then are we going to just use the outcomes of the analysis? For example, we produce several nice visualizations. We throw away all the initial data and we just store the very final set we used to create our visualization. This is a very important question because these days one of the big concerns in science is reproducibility. If we don't provide the correct data sets for use either of ourselves or other users, we risk not to be able to reproduce the same results. And the last bullets here are data are shared. Here we try to follow a principle that we share as open as possible, but as closed as necessary. Although here we have lots of people who believe that we should be sharing, not everything can be sharing. I will make a little comment on this. On the other hand, if you look from the research life cycle, we can do a very simplified version and look at research projects, because we all now work in environments where research projects are very popular. So what is important for research projects, they are limited in time and have to achieve something which is quite clearly set in the beginning. So we can look at three stages. How do we plan what we do with data? How do we handle data, how we curate data during the research, and then how we share data towards the end of the project. Of course, we can start sharing data earlier, but normally we are concerned with this when we are wrapping up our project. So there are many questions to ask and many different data requisites we have to think about. So this makes it really complicated. We don't have one solution which fits everyone for data management plans and for handling data in the different research projects. But we have to think, in my project, what are my data like? What policies do I need to follow? Who actually owns the data? Can I share this data? And what exactly I'm going to share? The raw data, the clean data, and so on. And here we can think about formats, volume, sources, collection, access, different things to consider. Then we have the data handling and curation during the research. How should I store my data? Where? How I'm using this? And again, we can think about plenty of different aspects: safety, size, security, backups, documentation, duplication. Apologies. These days, we have to think about the impact in the whole climate change discourse, and duplicating data in different repositories is not great. I have a student who now will be looking at how the legal deposit can be combined with the institutional repositories, because obviously this is one big area of duplication of data sets. Then when we arrive to the end of our project and we want to share data sets, we have these questions: what happens to my data after my project is over? How should I share? Where should I share? And also the important question on how I can check the use of data. So after I shared my data, can I actually say these data were useful to 1, 10,000 people? What did they do with my data? So these questions: what do I want to share? How to provide the context to explain my data set? Where exactly to share? How to check the use? Are questions we will be discussing in depth with the PhD students. This is much easier if the institutions have their clear policies, if they have recommendations for repositories. And here I want to share the outcomes of a recent report of the European Commission from 2023 on the access to and preservation of scientific information in Europe. It has a nice table which gives some information on the share of research performing organizations with a policy on data management. So these are all the countries, and these are data from 3 years ago, 2 or 3 years ago, so maybe now this is a bit different. But just for an idea, the data were collected: who has a policy on data management, who has a policy on fair data, and who has a policy on open data. These are different things. So if you look at Bulgaria at that point of time, and this might be now different, actually we didn't have any research performing organizations with policies on fair and open data, the two last columns, and we had less than half of the institutions had a policy on data management. So there is a scope to improve things, I suppose. Some other countries, the totally white boxes are where information was not provided. I see Italy in the list, so Italy didn't want to say what the situation is. That's not a criticism, I'm just looking at this. Very surprisingly, in that point, Cyprus was in the best situation, with all research performing organizations having policies on data management. Very impressive. So one of the aspects we have to unpack is whether we can open our data, or there are some considerations for closing the data. These are obviously forces which are going in the opposite directions. It creates some tension. Sometimes we cannot share data. Here we have a legal expert, so she would be able to explain this much better than me, but there could be legal reasons, copyrights, non-disclosure agreements, GDPR regulations. There could be ethical reasons related to responsible research. There could be reasons related to commercialization intentions, which delay our sharing of data until we get, for example, a patent application. So if you look at the open data, fair data, you will hear more about fair from Eva. And the well-managed data, I imagine that if we put them in bubbles, this will be the sizes. And we probably have a small intersection of data which are fair. Also, they're well managed. The fact that they're fair, that doesn't mean that all aspects of data management are brilliant. Maybe we have plenty of open data, but they're not always fair and managed properly, because they don't come only from research, but we have lots of data sets from government data, and they are and can be used in research. So this is quite a big bubble. Where we should put our data is always related to repositories, and it looks like there is a lot of choice. Not unfortunately in Bulgaria. If we speak about data, we still have to resolve this issue, but we are not restricted to deposit only in Bulgaria. There are subject repositories, discipline specific, which we can use. And here the choice is whether we go for general, institutional, national, discipline specific. And there is again lots of different aspects one can consider. One important thing is, are you depositing somewhere where you keep the rights on your data? Are there persistent identifiers? Can you make sure that if you don't want your data to be used to train AI, this repository will not sort of make this possible? There is a lot of discussions around metadata, but I'm not going there because we will spend ages discussing them. Besides metadata, now we also have paradata, which describe the processes how data were collected. Very important. And now I have, for a conclusion, a bit of food for thought from another report. The European Research Council is doing these regular updates on repositories which meet the requirements for compliance with Horizon Europe. So if you work on a Horizon Europe project and you want to deposit data sets, they have to go to repositories which are meeting the requirements. Why I took some outcomes out of this recent report? Because it says there is a difference between funder requirements and the repository systems, additional challenges because of the unclear in terminology. The report looked at 241 repositories. About 4/5 of them were fulfilling the model grant agreement definition of a trusted repository, and a smaller number were meeting the endorsement by specific research communities or the essential characteristics which are identified in the annotated grant agreement. So we can see that there are plenty of repositories, but not all of them are meeting all the requirements. Only 2 repositories, and both come from the humanities and social sciences, were exemplary. One is literature repository, HAL, and ours is the Austrian social science data repository. That's a bit of a look into the future. I think that what will matter a lot in the next year, besides fixing all our lacking data deposit infrastructure, in the more general sort of European context, would be responsible research, security aspects related to data and their use, matters related to artificial intelligence, including tools supporting research, the growth in scientific misinformation and disinformation, which can be supported by also spreading data sets which are not capturing properly the data. The green aspects and avoiding the duplication in various data infrastructures where the same data set is deposited multiple times. These are my own thoughts, so I cannot say whether all of these topics will come to a big discussion, but it seems that these are issues which need attention. Metrics on creating data sets and attention to the assessment. So what from the data sets we can take as a component of the research assessment. For the time being, there is not much which is taken into consideration. So if this topic is new for you, there are games. You can go on a research data management adventure, which has two branches for people from the humanities and from people from the STEMs. But obviously there is plenty of literature and guidance depending on what you want to do. So this was just an attempt to pick some of the main topics in this area.